Hello everyone, is my voice audible? Yes. Okay. So elementary statistics, only in TCS exam they ask this topic. Apart from that, in many other companies they don't give much importance to this. All right. Okay. So elementary statistics is, it's an advancement from the topic averages. Okay. It is an advancement from the topic averages. Statistics is basically used to, uh, you know, convert a huge amount of data into valuable information. For example, if you take, let us say, there is a manufacturing company, a production company, and they will take a survey, like how many of them are interested in, uh, you know, products that are sold for 10 rupees than products that are same product which are sold in a bulk quantity which is 50. So they will take a survey, and based on that survey they will identify, okay, which is better, right? What product shall I go with? So basically it is a survey taken upon, so among so many people or so many events that has already happened, and based on that coming to a conclusion on what can be done next. And this particular topic will be very helpful when you are getting into data science. All right. Okay. So what are we going to learn in elementary statistics? So we'll be seeing mean, which is nothing but averages. Then we will see median, mode, variance, standard deviation. Then also we will see mean deviation. So these are some of the concepts that we are going to learn under elementary statistics. We are going to see only the basics. Elementary itself represents basics. We will not be looking in-depth statistics. Whatever is the very basics of statistics, we will be learning only those things. And even the questions that are asked in TCS will be up to the same level. All right. First of all, we have to understand what are the different types of data we have. One is, the first one that we are going to utilize during this session is raw data. So average of 6 members of ages of 6 members of a family. So there are 6 members in the family, their ages are given. So from this you can find out average age of the family, right? Average age of the family, median age of the family, mode of the family. There is no mode here. Range of the age. Like this, there are multiple things you can get out of this particular data. So just a set of numbers. Okay, just a set of numbers. It's raw data. We'll be doing the calculation: mean, median, mode, range, standard deviation. All these things we'll do in the in this session. As of now, just try to understand what are the different kinds of data that they might be giving you. Ungrouped frequency distribution. For example, let us say you are conducting a test. Okay, let us say you are conducting a test, and for each correct answer, 10 marks will be given. Sorry, 5 marks will be given. So there are few students who got 10 marks. So if you say 10, how many students got 10 marks? 15 students got 10 marks. How many students got 15 marks? 12 of them. How many students got 20 marks? 30 of them. How many of them got 25 marks? 10 of them. How many got 30 marks? 5 students got 30 marks. So this is ungrouped frequency distribution. Why do we have to represent this? For example, instead of writing the data like this, so 10, 10, 10, like this, 15 times you will write 10. After that, 12 students got 15 marks. So 15, 15, 15, like that, 12 times you will write 15. After that, 20 students, 30 students got 20. So 20, 20, 20, like this. If you write it as a raw data, okay, it will be very long, too many values, very long to calculate, right? Very difficult to calculate this because of the huge amount of data. So to cut short it, to make it simpler, we represent them in ungrouped frequency distribution. This is, observation. This row represents observation. This row represents frequency of those observations. Okay. The second row represents the frequency. Frequency means how many times each observation occurs in the data. Okay, that is frequency of the observations. All right. So this is one kind of data, that is representation of data, ungrouped frequency distribution, or simply frequency distribution. Okay. If you have any doubts at any point, please put it in the chat section, or you can unmute and ask. The next data is grouped frequency distribution. Continuous class. What is the meaning of continuous class? See here, this is a class. What is a class? This is a class. For example, here 0 to 10, 5 is given, no? 2, 3, 7, 8, 9. This is the data. Then we have 11, 15, 14, 14, 16, 17, 18. This is one data. As you can see, in this class represents 0 to 10. Marks from 0 to 10. How many people have got marks 0 to 10? 5 of them. 10 to 20, how many of them got? 7. 20 to 30, how many of them got? 9. 30 to 40, how many are there? 6. 40 to 50, 3 students have scored. So like this, instead of giving the exact values of marks scored by everyone, this represents only a class of marks. Okay, so 0 to 10, how many are there? 10 to 20, how many are there? It represents only the class of marks rather than like in the previous data, set of data, exact marks. 15 students scored exactly 10. 12 students scored exactly 15. But here, there are 5 students who scored between 0 and 10. We don't know their exact values, but we know that it is inside this class. Now, let me give you one example. I want you to convert this into a table like this. Okay. Okay. So this is the data this. I want you to convert this into a continuous class, frequency distribution, grouped frequency distribution, continuous class. See, you can take classes like, 0 to 5, 5 to 10, or 0 to 10, 10 to 20, it doesn't matter. Class width, okay, doesn't matter. I want you to represent this in this table. This data, you have to put it in this table. This is marks and this is frequency. Zero to 10, 10 to 20, 20 to 30. How many students are there from 0 to 10? Here, there is a small complication. I want to explain that complication. That is why I have given this example. 0 to 10, how many are there? As you can see, 1, 2, 3, 4, 5, 6, 7. There are 7 data which are in the range 0 to 10. And also 10 to 20. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 data are there. But this 10, it can come here also. But there is one rule on where we should put it. Okay. This 10, we should not keep it here. We should keep it in this range from 10 to 20. From 0 to 10, this 10 will not be included here. That means there is only 6 data. 1, 2, 3, 4, 6, 9. Only 6 data in the range 0 to 10. In continuous class, if one of the data belongs to the lower limit, that has to be included in this particular class. Here 10 to 20, 1, 2, 3, 4, 5. 20 should be included here, not here. So there are 5 data which are in the range 10 to 20. 1, 2, 3, 4, 5, 6. There are 6 data which are into the class 20 to 30. Do you have any doubts so far in this? How to convert this raw data into, put into classes? Do you have any doubt in this? Okay, Sachin, which part you didn't understand? Okay, see, in continuous class, what happens is this class has data from 0 to 10. This has 10 to 20. Now, if I have this data 10 here, I have 10, right? Where should I put it? That is the confusion. Should I mention it here and also here? If I do that, I'll be counting this data twice, whereas it is occurring only once. So if you have a data which is the lower limit of any class, okay, 10 is the lower limit of this class. So if you get the data, you have to put it in this class, not the data, not the class where the data is the upper limit. Are you getting it? You have 10, class boundary is 10, right? And lower limit is 10. So wherever this value becomes the lower limit, in that class you have to put it. 1, 2, 3, 4, 5, 6. There are 6 data which are in the range 0 to 10. There are 5 data which are in the range 10 to 20. And there are 6 data which are in the range 20 to 30. So frequency means how many times a mark in this range, how many times occurs? 6 times. In this range, how many times marks occurs? 5 times. From 20 to 30, 6 times it occurs. Understood, Sachin? Yes. So this is grouped frequency distribution, continuous class. Remember, guys, there is another class called as discrete class. Before making any calculation, you have to convert it into continuous class. Only then you have to do the calculation, whether it is mean or median or standard deviation or whatever it is. A discrete class should be converted into continuous class. Only then a calculation should be made. So let us see an example of discrete class. Or first, let us understand the terminologies used here in continuous class. We have 0 to 10. This is a class. This is the second class, third class, fourth class, and this is the fifth class. Okay. UCL means upper class limit. Upper class limit means if I take, what is the UCL of this upper class limit of this class? 10. That is the maximum value of this class. It's called as upper class limit of a particular class. Here, UCL is what? 20. 20 is the upper class limit of this class, right? What is the LCL of this class? Lower class limit, 0. Here, what is the lower class limit? 10, right? So in continuous class, upper class limit of a particular class will be same as lower class limit of the succeeding class. Okay, class boundaries, you can say class limit or class boundaries, like that you can say. Class interval is upper class limit minus lower class limit, or sometimes this is mentioned as class width also. Class width represented using the term H. Okay, class width H. So 10 minus 0, 10 is the, here 10 minus 0, or 20 minus 10, or 30 minus 20, provided, see, in elementary statistics, we will be dealing with classes which are of same width. Okay, we will be dealing only with those kind of classes. In advanced statistics, you will have classes with variable widths. But here, in elementary statistics, we will be dealing only with class widths of same width. Classes with same width. What is class mark? Now, see, if you take this data, there are 0 to 10. There could be any number of values in this range, right? Any value could be there. 5 terms are there. See, if you take this part alone, okay, this part alone, 1, 3, 8, 9, 7, this could be the data, right? We have 5 elements here in this range. We don't know what to exactly consider as middle value. Okay, what a single value representation, we don't know. Should I mention it as 1? Should I mention it as 3 or 8 or 9 or 7? We don't know that. So to represent this class using a single value, we take the middle value of that. Middle value is nothing but 0 plus 10 divided by 2. That is average of upper class limit and lower class limit of that particular class. So basically what we are thinking is the average of this class. We are assuming, we are not sure about it, but we are just assuming it here. Average of this class is 5. Average of this class is 15. Average of this class is 25. Here average is 35. Here average is 45. So when we have to do mean calculation or median calculation, this class mark will be very helpful. We are only assuming it. We don't know the exact thing, but we are assuming it by, see, sometimes calculating mean, median, and mode to decide which is better option, you don't need the exact value, but a closer value is sufficient. So that is why whenever there is huge amount of data, so imagine this is 500, 700, 900, 600, 300 instead of 5, 7, 9, 60. Okay, if you have a huge amount of data, after you put them into classes like this, you don't need the exact value of your average or mean or median or mode, but if you can have at least approximate value which is very close, if I can calculate that in a simpler way, it will be beneficial for me. I want the average, but I don't want exact value. I need approximate value. Let me go with continuous class grouped frequency distribution. So that is how these kind of concepts are very helpful in manipulating or getting information out of huge data. Okay, here it may be small, but remember this, statistics, data science, and all these things deals with huge amount of data, and these kind of techniques help us get the required information in a simpler way. Okay, class boundaries means 0 is the boundary, 10 is the boundary. Like this, 10, 20, these are the boundaries. Upper class limit and lower class limit, these are the class boundaries. Okay. Any doubts so far, anyone? All right. So group frequency distribution, you can also call it as non-continuous class. Okay, discrete class or non-continuous class. As you can see here, 1 to 10, 11 to 20, 21 to 20, 30, 31 to 40, 41 to 50. Now, in these kind of data, in this type of representation, what is the issue? If you have a data 20.2, okay, if you have this data 20.2, you can't put it in any of these classes. Okay, you cannot put it in any of these classes. That is why we convert these kind of discrete classes into continuous classes, and then we do the calculation. All right. Now let us see how to convert a discrete class to continuous class. Now what you do is add these two values and then divide it by 2. 10 plus 11 divided by 2 is how much? 10.5. So that means from this 10, you are adding 0.5, or from this 11, you are subtracting 0.5, right? So when you convert this class, what happens is it will become 0.5 to 10.5. This is one class. 10.5 to 20.5. This is another class. 20.5 to 30.5. Like this, it will get converted to continuous class. 30.5 to 40.5. Then 40.5 to 50.5. Right? So like this, we will be converting a discrete class to a continuous class. Now tell me, what will be the limits or class limits of this? Convert this table to continuous class. Age, frequency, 10 to 15, 20 to 25, 30 to 35. Here, after you convert this into continuous class, what will be the class limits of each class? $15 and $20 are there, no? So what do you do? 15 plus 20 divided by 2. 35 by 2 is what? 17.5. So 17.5, 17.5. Right? Here, 25 plus 30 divided by 2 is 22.5, or mid value of 15 and 20. What is mid value of 15 and 20? 17.5. Mid value of 25 and 30 is 27.5. So 27.5 to 37.5. Here, it will be 7.5 to 17.5. So like this, you will be converting a discrete class into a continuous class. Do you understand, everyone? Remember this, whatever calculation you are going to do, mean, median, mode, standard deviation, or whatever it is, if you see a discrete class, you have to convert it into a continuous class. Only then you have to do the calculation. Okay. Understood, guys? Shall we go to the next one? All right. Now, the first thing that we are going to see is range. So range of raw data. So if a set of this, most of you will know how to do, right? If a set of data is given, you have to identify the maximum value in that data and minimum value in that data. And based on that, you will be calculating the range. What is the maximum value here? 25. 26 is the maximum value. Maximum value is 26. What is the minimum value? 2. Right? 2 is the minimum value. 26 minus 2, 24. That is the range. Now, see here, guys, why we use this range? Let's say there is a batsman. Okay. Let's say there is a batsman. In first match, he scored 12, then 36, then 42, then 6, then 19, then 64, then 108, then 94. And there is another batsman. Okay, there is another batsman. How many matches are here? 8 matches, right? So in first match, 56, then 42, 53, 69, 72, 84, 46, 34. Here, for the first batsman, the maximum score is 108. Right? Maximum he has scored 108. Just because of the maximum value, can you decide that this person is a good player? Batsman 1. Based on this, whom will you decide is a better batsman? Batsman 1 or batsman 2? Both of them have played same number of matches, right? Among these two batsmen, who is a better option? For example, if you have to bet on someone, okay, you have to bet on someone, whom will you choose as a better option? First one or second one? Second one. Very good, Sachin. Why? Because the first batsman, okay, he scored from 6 to 108. His variance is too much, right? If you draw a graph like this, okay, 6 is here, 108 is here, and other values are between this, right? Other values are between this. But if you take this batsman, okay, this is 0 and this is 110, let us keep 0 to 110. If you see this batsman, his least score is 34, right? His maximum score is 84. His dispersion is very less compared to the previous batsman. If you select the previous batsman, there is a possibility he will get run out in or get out in 6 runs also. There is a possibility, even though there is a possibility that he might score up to 108, consistency is more with respect to second batsman. This is how statistics helps us, guys. Okay. This is how statistics helps us to predict what would happen. This is how statistics helps a robot to understand for certain kind of questions what kind of actions to be performed. Right? Okay. So range is not the exact only parameter which can be used to predict what will happen in the future. But apart from range, there are so many other data: mean, median, mode, standard deviation, variance. Each of those increase the level of prediction that we are going to. Mean gives the least feasible prediction. Standard deviation gives the most feasible prediction. Like this, the level of prediction keeps on increasing stage by stage. Okay. So if you see range of ungrouped frequency distribution, here maximum value 30, right? Minimum value is 10. So 30 minus 10, 20. The range is 20. So minimum value of the given data is 10, maximum value in the given data is 30. So 30 minus 10, 20. That is the range. Okay. In grouped frequency distribution continuous class, okay, 50, upper class limit of the maximum interval. This is the maximum class interval. In that upper class limit minus lower class limit of the minimum interval. 50 minus 0 gives 50. This is the range of this particular set of data. Right? Finding range is very simple. Now, if it is a continuous class, it's very simple like this. What if it is a discrete class? You see here, range of grouped frequency distribution, discrete class or non-continuous class. In this case, you have to make it into a continuous class. Only then you have to convert or find the range. 10 and 11. So 10 plus 11 by 2 is 10.5. So that means you are adding 0.5 to the upper class limit, UCL, plus 0.5. Lower class limit minus 0.5. So what will be the range now? Or what will be the class limits now? Once you convert this, 0.5 to 10.5, 10.5 to 20.5, 20.5 to 30.5. So like this, it will go up to 50.5. Now, 50.5 minus 0.5 is your range. Okay, 50.5 minus 0.5 is equal to 50. If you don't do this, if you just do 50 minus 1, range is not equal to 50 minus 149. This is not the range. Okay, this is wrong. Okay. Understood, guys? How to find out range? Okay. Is the screen visible now? Yes. Okay, great. Now, before getting into the next part, sometimes this cumulative frequency, finding this cumulative frequency will be very helpful. Now see here, there are 5 students who scored exactly 10 marks. So here the cumulative frequency is 5. 15 students scored 6 marks, or up to 15. Up to 10 marks, we have only 5 students. Up to 15, we have 5 plus 6 equal to 11 students. Okay. What is this 11? Up to 15, how many students are there? 11. Up to 20. Up to 20, how many students are there? 11 plus 8, 19 students are there. This 11 plus 8, or 5 plus 6 plus 8, 19. So up to 25, how many students are there? 19 plus 11, 30. Up to 30, how many students are there? 30 plus 13, 43. Up to 35, how many are there? 43 plus 10, 53. Up to 40, how many students are there? 53 plus 9, how many students are there? 62. This 62 is nothing but n, which is number of observations. Total number of observations. You can directly 5 plus 6 plus 8 plus 11 plus 13 plus 10 plus 9. You can just put it like this, sum of observations. Okay. Like this, they will use symbols and all, but I am trying to teach you with symbols and notations. Okay. Try to understand this. But if you are referring frequency, summation of frequency from I equal to 1 to n. So like this, number of classes, how many hours is there, like that they will do it. Summation of frequencies. Okay. Fine. So here, less than 20. See, in continuous frequency distribution, continuous class, what we do, if you get 20, you will put it in this class, right? If there is a mark, if there is a data which is 20, you will put it in this. So that means all data in this class should be less than 20, right? All data in this class should be less than 20, because if you get 20, you will put it in the second class, right? So here, less than 20, 12 students are less than 20. Less than 30, if they ask you how many are less than 30, 12 plus 17, 29. So less than 40, how many are there? 29 plus 25, 54. Less than 50, how many are there? 54 plus 30, 84. So like this it will go on. 36 is 120, then 165, then 217, then we have 227, then 230. So total frequency, so total number of observations is 230, right, which is n, number of observations. So cumulative frequency, sometimes it will be very helpful. Sometimes they will even give data like this. You should be able to convert this kind of cumulative frequency table to continuous frequency table. So let me give you a cumulative frequency table. This you have to convert into a continuous frequency table. So let us say marks, number of students. Okay. Less than 10. There are 8 students who are less than 10. less than 20. 10 students are there. Less than 30. 40 students are there. Less than 40. 48 students are there. So when they give a table like this, when they represent the data like this, you have to convert this into a continuous class group data continuous class. Okay. How do we do this? Very simple. Marks, number of students. Now here 10, 20 is there. 10 and 20. What is the difference between 10 and 20? 10. That means class width should be 10. So 0 to 10. Then 10 to 20. Then 20 to 30. Then 30 to 40. These are the 4 classes. Now this value will be same as this value. Here 8. Now 10 minus 8 equal to 2. This is the number of students in this range, 10 to 20. See, up to 20, less than 20, there are 10 students. Less than 10, there are 8 students. That means 10 to 20, there are only 2 students, right? 0, 20, 10. 0 to 10, there are 8 students, right? 0 to 20, there are 10 students. That means there are only 2 people in this range, 10 to 20. The remaining 8 are below 10. So this is nothing but 10 minus 8. That is 2. There are 2 people in this range. Now there are 40 people here. Before this 40, there are 10 people, right? So 40 minus 10 will give you this one, 30. There are 30 students in the range 20 to 30. Now 48 minus 40 will give you 8. There are 8 students who are in the range 30 to 40. So when they give data like this, okay, before calculating mean, median or mode or range or whatever it is, you have to convert this into a grouped data continuous class in this manner. After that, you can start doing your calculation. Any doubt in this conversion, anyone? All right. Great. Now we will be trying to find out mean of raw data, ungrouped data. Then we will be trying to do for continuous class, discrete class. These 4 categories we are going to find out mean. Mean is nothing but average. What is the mean of this data? 12, 26, 8, 10, 15, 19 and 20. Add these values and divide it by number of terms. Usually they represent, in statistics, they represent mean using this terminology, this notation X bar. Sum of all the observations divided by number of observations. Okay, this is how they try to calculate mean, but it's just average. You don't have to complicate with these things. Just for your understanding, I am just putting it here, but directly do this. 12 plus 26 plus 8 plus 10 plus 15 plus 19 plus 20 whole divided by how many terms are there? 1, 2, 3, 4, 5, 6, 7 terms are there, right? 38, 46, 56, 61, 71, 80, 90, 110, 110 by 7. That is 35 point, 35 point something like 58 something, 35.7. Yeah. 35.7 will be the answer approximately. Okay. Now, in last year TCS, they asked so many questions. In so many slots, they asked this question. If mean of a set of data is 40 and each observation is increased by 6, what is the new mean of the data? This we saw in our averages concept, right? When every value, if every data is increased by a certain value, average will also increase by same value, right? 40 plus 6, 46. That's all. Okay. I just wanted to mention this because many slots they had this. Okay. It's 15.714. Now, there is one more concept called as assumed mean. To find out this mean, we have another method to solve, which is called as assumed mean. What is that? I will take very simple values to make you understand this. You can simply say average for these numbers or mean of these numbers is what? 30, right? So let me take a different example. Since 8 terms are there, average of middle 2 terms will be the average of this complete set, right? They are in arithmetic progression. So average of middle 2 terms or average of first term and last term divided by 2. So this is 45. This is well known for us. But we are going to do assumed mean. What is that assumed mean? I will take any one element from this series and I will assume that it is the mean. So let us say assumed mean, which is represented using the term A, is equal to 50. Okay. Now see here. First term is 10. 10 minus 50 is how much? Minus 40. 20 minus 50 is minus 30. 30 minus 50 is minus 20. 40 minus 50 is minus 10. 50 minus 50, 0. 60 minus 50, 10. 70 minus 50, 20. 80 minus 50, 30. Now, I will add all these values. Plus 20, minus 20, plus 10, minus 10, plus 30, minus 30. These will get cancelled. So, you will be left out with minus 40. Okay, minus 40. This minus 40 divided by number of terms. How many number of terms are there? 8. What is that? Minus 40 by 8 is minus 5. Okay, to this A, this is mean deviation. This is called as mean deviation or deviation of the average. Okay, deviation of the mean or deviation of the average, which is represented using the term D. So A plus D, okay, A plus D will give you the mean. Okay, in assumed mean concept, A plus D, assumed mean plus mean deviation will give you the actual mean, or assumed average plus deviation in average will give you the actual average. Remember this. So A is 50, D is minus 5, which is equal to what? 45. Okay. Now, why this is helping us? Sometimes calculating average, calculating this mean will be time consuming. In those cases, we will be using this technique to find out the exact average, which will be like, see, many items will get cancelled. So in this case, it will become little easier, or even we will get smaller values. Using those smaller values and finding out the assumed mean deviation, and then using assumed mean and adding these two, getting the actual mean. Sometimes it will be helpful. I just wanted you to understand how this works. Okay. In some cases, we will be using it. We will see where and all we will be using it. All right. Assumed mean method. This is how we do it. Assumed mean plus mean deviation gives the actual mean. Okay. Done. Let us see the next one. Mean of ungrouped data. Guys, this is very simple. You don't have to worry about it at all. We have already seen this in average. The concept called is weighted average. Do you remember this, guys? Weighted average. Overall average is equal to A1N1 plus A2N2 plus A3N3 and so on divided by N1 plus N2 plus N3 and so on. This concept, do you remember? Same thing here is. There are two students who go scored 10 marks. What is the sum of these two students? Sum of the marks of these students? 10 into 2. This will be the total marks scored by these two students. Total marks scored by these 6 students will be what? 15 into 6. 15 marks scored by 6 students, so total will be 15 into 6. 20 marks scored by 5 students, so 20 into 5. 25 marks scored by 4 students, 25 into 4. 30 marks scored by 1 student, 30 into 1. Whole divided by total number of students, 2 plus 6 plus 5 plus 4 plus 1. Okay. So mean is equal to 20 plus 90 is 110, 110 plus 200 is 310, 310 plus 30 is 340, 340 divided by, this is 8, 13, 13 plus 5, 18. Did I do the calculation correctly? 20, 110, 210, 310, 340, 340 by 18. So approximately this is 18.88 you will get. Okay, approximately 18.88. That will be the mean of this particular data. Okay, so here mean of ungrouped data, the usual representation in statistics is sum of Fi xi divided by n. So basically frequency of first data into average of first data. Okay, frequency of first data is 2, average of first data is 10. Frequency of second data is 6, average of second data is 15. Like this they will mention it, but the calculation is this one. It's very easy to understand if you compare it with averages concept. Okay, so this is how we find out mean of an ungrouped data. Let us check for grouped data. How to find out mean of grouped data? Now, this is same as finding weighted average. Okay, this is same calculation as weighted average. Only additional thing is, they will not be giving this particular part. They will not be giving this directly. They will give this data, marks and frequency they will give. This class marks is there, no? That we have to find out. We initially saw in this, concept, right? What is class mark? Class mark, how do we find out class mark? Upper class limit plus lower class limit divided by 2. That means 0 to 10 means in an average, we assume average of this data is 5. We assume the average is 5. The middle value, midpoint. Okay. So 10 to 20, midpoint is 15. 20 to 30, midpoint is 25. 30 to 40, midpoint is 35. 40 to 50, midpoint is 45. 50 to 60, midpoint is 55. Here, the mean will be, class mark is xi, frequency is fi. Okay, 1 by n into summation of fi xi. Okay, this is the mean. So what you have to do is 15 into 12 plus 25 into 17 plus 35 into 25 plus 45 into 30 plus 55 into 36 whole divided by 12 plus 17, 29, 29 plus 25 is 54, 54 plus 30, 84. This is 120. Right? So this will be the mean of this particular set of data. Do you understand, guys? See, the answer that you are going to get here will not be the exact mean of this data, because we don't know from 10 to 20 what are the values are there in this class. We don't know, but we are assuming this 15. The mid value we are assuming, and based on that we are doing this calculation. This will not give exact value, but it will give you the approximate value. Any doubt in this, anyone? Extra only one step is there. What is that? You have to use the class mark, because 10 to 20 you don't know which value to take, average value. So the mid value you are taking and doing it. Simple. Understood, guys? Yeah. Okay. If it is a discrete class, as I told earlier, whenever you see a discrete class or non-continuous class, you have to convert that into a continuous class and then do the operations, right? So note down this, very important. Discrete classes must be converted to continuous classes before calculating mean, median, mode, or range, or whatever it is. Not just these three. Okay, whatever calculation you are doing, convert it into a continuous class and then do it. Okay. Now, before getting into mode, okay, let us take a small break. All right, 5 minutes break. 7 o'clock we will start again. All right. Okay. So this you can find out the answer. Just see what is the mode of this and try to give the answer in the chat before we start again. Yes, guys. So what is the mode of the given data? As you can see here, mode is the data that is appearing most frequent, most frequently. Okay. Here, as you can see, check for the numbers. 12 occurs 1, 2, 3 times. 14 occurs 1, 2, 3, 4, 5 times. 13 occurs 1, 2, 3, 4 times. 15 occurs 1, only once. 16 occurs 1, only once. 17 occurs 1, 2 times. 18 occurs 2 times. So whichever is the highest value, highest number of times whichever data is occurring, that is the mode. So here mode is equal to 14. Okay, 14 occurs most number of times. Okay. Finding mode is very easy, for especially for raw data. And finding mode, okay, before that, bimodal data. What is the meaning of bimodal data? It will have two modes. That means two data will occur equal number of times and also highest number of times. Okay. So as you can see, 12 occurs 1, 2, 3 times. 13 occurs 1, 2, 3, 4 times. 15 occurs 1 time. 16 occurs 1 time. 17 occurs 2 times. 18 occurs 1 time. 14 occurs 1, 2, 3, 4 times. Right? So that means here two values occur most frequently and also highest number of times. So the modes are 13 and 14. These are the modes. Any data that has more than one mode, we can call it as multimodal data. Okay. Any data that has more than one mode, that we can call it as multimodal data. Okay. So here, mode of an ungrouped data. This is very easy. easier than finding out the mode of raw data. Whichever has highest frequency, okay, whichever has highest frequency, that is the mode. Here 11 has the highest frequency, so mode is equal to 11. So the age 11 occurs most number of times in the data. This is our mode. All right. Now remember this, guys. Whenever they give cumulative frequency distribution, okay, whenever they give cumulative frequency distribution like this, okay, you have to convert it into a frequency distribution, continuous frequency distribution table like this, and then only you have to take the mode. So if you directly take from this, you will say 48 is the mode, but so this 40 is the mode. No, it is not correct. Here mode is this one, 20 to 30 is, this is the modal class. Okay, modal class that we will see in the next example. If you have a grouped data continuous class, okay, first you cannot find the mode here. You cannot find mode, but you can find modal class. What is modal class? The class with highest frequency. The class with highest frequency is called as modal class. Class with highest frequency. The class which occurs most number of times is called as modal class. Okay. Here, as you can see, this class occurs most number of times. Data in this class occurs most number of times. So this class is called as modal class. Are you understanding this, guys? Yeah. Now, when you have a grouped data continuous class, how do you find out mode? Use this formula. Mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. Now, what is F0? This is F1, frequency of modal class. Previous one is F0. The next one is F2. Okay. This is F0. This is F1 and this is F2. Okay. Now, what is L? Lower class limit of the modal class. Lower class limit of modal class is L. So here L is 20. In this modal class, lower class limit is 20, right? F0 is the frequency of the class preceding the modal class, 7. F1 is the frequency of the modal class, 9. F2 is the frequency of the class succeeding the modal class, 6. H is size of the class interval or class interval, class width, 20 to 30. That is, or any class you can take. All classes are having same width, right? So 30 minus 20, 10. Now substitute these values in the formula, you get the mode of the given data. So here mode is equal to L. What is L value? 20 plus F1 is 9 minus 6 divided by, minus 7 divided by 2 into 9 minus 7 minus 6 into 10. So 20 plus 9 minus 7 is 2. 2 divided by 18 minus 7 minus 6. 18 minus 13 is 5 into 10. 5 into 10 is how much? 5 by 10. 10 by 5 is 2. 2 into 2, 4. 20 plus 4 is 24. So this is the mode of this particular data. So remember the formula. Using this formula, you can find out mode for this particular class. Remember guys, if they had given cumulative frequency, you have to convert it into continuous class and then do this calculation. If they had given discrete class, you have to convert this into continuous class and then find out the mode. Okay, very important. Whenever you see a cumulative frequency class that is less than 10, less than 20, or up to 10, up to 20, something like that, you have to convert that into continuous class, as well as discrete classes should be converted to continuous class, and then only you have to calculate the mode. Whatever calculation, median or mode you are doing for grouped data, it should be converted to continuous class, only then you have to do it. Remember that. Okay. Let's go to the next one. Now we are finding out median of the classes or median of the data. Now median of raw data when the number of observations is odd. Median is nothing but middle value. Okay, median is nothing but middle value. Now, if the number of terms is odd, n plus 1 by 2th term, that is the median. As you can see here, 1, 2, 3, 4, 5, 6, 7 terms are there. But before that, we have to arrange them in ascending order or descending order. It doesn't matter which order. Okay, it should be either ascending or descending. Only then you have to do. What is the smallest value here? 24. After that, we have 34. After that, we have 43. After that, we have 56. We have 2 times. Then we have 73. Then 78. This is the ascending order of given data. 7 terms are there, or middle term. This is your median. Okay. 7 plus 1 by 2th term. That is 4th term is the median after arranging them in ascending or descending order. In both sides, ascending or descending, 56 will be the middle value or 4th term, right? So that is your median. What if number of terms is even? For raw data, we have to find out the median where the number of observations is even. In this case, median is average of n by 2th term and n by 2 plus 1th term after arranging them in ascending order. First, you have to arrange them in ascending order. Then you have to take the average of middle 2 terms. Okay. So first arrange them. The smallest value here is 24. After that, we have 34. After that, we have 43. Then 56. Then 56. Then 64. Then 73. Then 78. 1, 2, 3, 4, 5, 6, 7, 8. Right? 8 terms are there. So that means middle 2 terms are these 2. Right? So 56 plus 56 divided by 2 is 56 itself. So that will be the median. Okay. So that means 8 by 2th term plus 8 by 2 plus 1th term divided by 2, that is 4th term plus 5th term divided by 2. So 56 is the answer, median of this data. All right. Okay. Now, ungrouped frequency distribution. For this, let us find out what is the median. Odd number of terms is there. Median of ungrouped data, odd number of terms. Okay. Here, whenever they have given a table, data like this, they have represented data like this. Age 15, 16, 12, 10, 20. First, you arrange them in ascending order. Arrange in ascending order. This is very important. Don't take it as it is. Arrange in ascending order. 10 is the smallest number. Then we have 12. Then we have 15. Then we have 16. Then we have 20. This is the age range from 10 to 20, right? After this, number of students, 10. At age 10, how many are there? 8. Age 12, how many are there? 6. Age 15, 3 are there. Age 16, 9 are there. Age 20, 1 person is there, right? Cumulative frequency, find the cumulative frequency. 8, first one will be same as this one. Then 8 plus 6 is 14. 14 plus 3 is 17. 17 plus 9 is 26. 26 plus 1 is 27. Now what you do is 27 plus 1 divided by 2. What is 27 plus 1 divided by 2? 14. Now 14 is in this range. 14 is here, right? 14 is in this range. Even if you get 13, above 8, before 14, after 8, before 14, right? Even if you get 12, after 8, before 14, like that. So the median is 12. Okay, this is the median. Do you have any doubt in this question, anyone? Do you have any doubt in this technique? See, not always you will find out 14. For example, instead of 1, let us keep it as 3. Okay, let us keep it as 3. So what will become? It will become 29, right? Instead of 1, we'll keep it as 3. So 29. 29 plus 1 divided by 2, that is 15. Where is 15? Fifteen is after this and before 17, right? After 14, but before 17. So here, whatever is the age, that is the median age. 15 is between 14 and 17, right? So you have to take this class, this age value. So median age is 15. What if you get 9? If you get 9 also, you have to take this one only, 12. 9 will be, see, up to 8, 0 to 8, 14, 14 to 17. So any value you get from here to here. Okay. So accordingly, you will say 12 is the median. From here to here, if you get any value, then 15 is the median. Like this you will put. Understood, Pawan? Yes, okay. So even number of terms are there. First, we arrange in ascending order, right? 10, 12, 15, 16, 20. These are the ages. Number of students. In 10, we have 7. In 12, we have 5. In 15, we have 3. In 16, we have 11. And in 20, we have 2. Cumulative frequency. Find out the cumulative frequency. 7. This is 12. 12 plus 3 is 15. 15 plus 11 is 26. 26 plus 2 is 28. Now, when you have even number of terms, okay, if n is equal to 28, which is even. In this, n plus 1 by 2. What is n plus 1 by 2? 14.5. So whichever is there, 14.5. 14.5 is here, right? Before 14.5 we get. Am I right? Before 15, we get 14.5. So this is your median class or median age. All right. Same thing, whatever you are doing here, same thing you will be doing here also. Whether it is odd or even, plus 1 divided by 2. That's what you are going to do. Okay. So one more example. 10, 12, 15, 16, 20. 10 we have 7 students, 12 we have 5 students, 15 we have 3, 16 we have 11, and 20 we have 4. Okay. Cumulative frequency 7, 12, 15, 26, 30. Right? 30 plus 1 divided by 2, 15.5. So it comes here. So 16 is the median class, median age. $15.5 is after 15. So the group after 15 should be considered for median. Okay. All right. Now let us, for continuous class, let us see how to find out median. This is the formula L plus N by 2 minus CF divided by F into H. L means lower limit of the median class. First of all, we have to find out what is the median class, right? We have to find out what is the median class. After that, we have to do this. So what is median class? First, do the cumulative frequency 0 to 10, 5 are there, 10 to 20, 16 are there, 21, 20 to 30, 21 are there, right? And 30 to 40, 38, and 40 to 50, 42 are there, right? Now, cumulative frequency is, this is 5, this is 21, this is 42, 42 plus 38 is 80, 80 plus 42 is 122. Now, when you have this 122, 122 divided by 2 is how much? 122 divided by 2. 61. 61 comes under which range? After 42, before 80, right? 61 comes after 42. And before 80. So this is your median class. Okay, this is your median class. If the number of terms is odd, okay, if n is equal to odd, what will you do? N plus 1 by 2. Okay, n plus 1 by 2. If it is odd. So, okay, now we have found out the median class, right? Now, based on this, let us calculate the median. L value, lower class limit of the median class, 30. 30 is the lower limit of median class, L. N is number of observations. What is the total number of observations? This one is the total number of observations. Okay, N is equal to 122. Cumulative frequency of CF means cumulative frequency of the class preceding the median class. This is our median class. This is our cumulative frequency before the median class. So 42. F means frequency of the median class. So 80 is the frequency of the median class. This is F. And H is class size. That is very easy. 10 minus 0 or 20 minus 10 or 30 minus 20. So 10 is the class size. Now substitute these values to find out the median. 30 plus n by 2, 122 by 2 minus cumulative frequency of the preceding class is 42 whole divided by frequency of the median class 80 into height, that is 10, right? So this will be 30 plus 61 minus 42 is 19. So 19 by 8. 19 by 8 is 2.375. So 32.375. This is the median of this continuous class, right? So the only thing complicated so far we have seen is two formulas. The other things are very easy. And remember, guys, when you are using these techniques in TCS NQT exam, use calculator. Don't try to do this on your own. You have calculator, use the calculator, substitute the values, get the answers easily. Okay. All right. So two formulas for mode, we have seen one formula. We have for median, we have seen one formula. So just use these formulas to get the answer. Remember these formulas. They also call it as imperial relation. Means it is not a proven one, but by practice, they have most of the time they have seen that 3 into median is equal to mode plus 2 into mean. Okay. So this, based on this, there is a huge chance that you will get a question. So let us say if mean is equal to 5, median is equal to 3. So then what is the mode? If they ask, you just substitute it here. So 3 into 3 is equal to mode plus 2 into 5. 9 is equal to mode plus 10. So mode is equal to minus 1. So like this, you can try to implement this formula. Okay. Imperial relation between mean, median, and mode. All right. Okay. Calculating mean using assumed mean. So we have already seen one example, right? Now let us see one more example on how to calculate mean using assumed mean. First, arrange in ascending order. Are they in ascending order? Yes. So let us say assumed mean A is equal to, let me take 20 as the assumed mean. It doesn't matter which you take. You can take 14. It doesn't matter. Okay. Smallest value, largest value, any value in this you can assume. This is just assumption, right? Is it compulsory that you have to assume the value given in the series? That is also not there. You can even assume any value within this range. 15 also you can assume. You can assume 100 also, which is outside this range. It doesn't matter. Answer will always be proper. So we are just assuming 20. So 14 minus 20 is minus 6. 16 minus 20 is minus 4. 18 minus 20 is minus 2. 24 minus 20 is 4. 30 minus 20 is 10. Add these values. Minus 4 minus 6 is minus 10. And this cancels. Minus 2, this is 2. Sum of these values is 2. Now, this is mean deviation. Okay, this is called as mean deviation D is equal to 2. Sorry, mean deviation. This is not mean deviation. Mean deviation is equal to 2 by number of terms. What is 2? Sorry, number of terms is 6. 2 by 6 or 1 by 3. So actual mean is equal to A plus D. So 20 plus 1 by 3, which is 61 by 3, right? Or 20.33. This is the actual mean. If you add these values, what happens? 14 plus 16 is 30. Then 48, 58, 68, 72, 82, 92. 92 plus 30 is 122. 122 by 6 is nothing but 61 divided by 3, which is 20.33. So assumed mean method, you can use it to find out the mean. For this data, for raw data, okay, it will be complicated. Okay, when you are applying this technique for raw data, it is complicated. For raw data, why will you go with all these things? You can directly, add them and divide it by number of terms, right? But for ungrouped data or grouped data, it will come in handy. See, we don't know the mean 20, 30. See, to find out the actual mean, what you should do? 20 into 1 plus 30 into 2 plus 50 into 3 plus 60 into 4 plus 80 into 5 whole divided by 1 plus 2 plus 3 plus 4 plus 5. Instead of that, we will assume a mean. Let us say this is the assumed mean A. Okay. See here. 20, 20 minus 50 is minus 30 minus 20 0 10 30, right? So minus 30 into 1, this is minus 30, and this is minus 40, this is 0, 40, and this is 150. So this and this will get cancelled. 120 we are getting. Okay, this 120 should be divided by total number of terms 5, 24. This is your actual mean. Sorry, this is your mean deviation. So 50 plus 24 equal to 74 is your actual mean. This is deviation, mean deviation. A plus D is equal to actual mean. 74 is the actual mean here. Okay. Understood, guys? So if it is a continuous data, grouped data, continuous class, what will you do? Simple. Take the class mark. Xi nothing but class mark. So middle value is 10, here 30, here it is 50, here it is 70, here it is 90. So let us say this 50 is our assumed mean. Okay, 50 is our assumed mean. So what will happen in this case? 50 minus 10 is minus 40. Right? 50 minus 30 is minus 20. This is 0. 50 minus 50 is 0. 70 minus 50, 20. 90 minus 50, 40. 4 into minus 40 is minus 160. 6 into minus 20 is minus 120. This is 0 plus 120. This is 400 plus 400. Right? So this is 240. Sum of these values is 240. 240 divided by 5 classes are there. 240 divided by 5. What do you get? 48. A plus D. This is deviation. A plus D. You will get, actually here, sorry, this one should be N. This should be 15. 120 divided by 15, 8. Right? So 50 plus 8, 58 is the answer. Not number of terms, like not number of values, it is number of terms, total number of terms, N. D is equal to sum of Fi Di divided by total number of terms. Here it should be 4 plus 6, 10, 10 plus 8, 18, 28. 240 divided by 28. So your actual average will be A plus D. A plus D will be what? 50 plus 240 by 28. 50 plus 240 by 28. Whatever value you are getting, that will be the answer. Okay. Is it 8.57? Okay. So 58.57. This will be the actual mean. Okay. Got it, guys? So A plus D, which is nothing but A plus summation of Fi Di divided by N. Remember this. Assumed mean. Okay. See this one? Mean deviation about mean. Mean deviation about mean means, what is the deviation of mean? Average deviation from the mean. For example, let us say we have a set of data 0 to 100, let us say. Deviation is nothing but data difference mean. See, let us say the average is this one. This is the average. Okay. The data is the average deviation of the data from the actual average. That is what they are asking. For example, one value is here, another value is here, one value is here, and another value is here. If you see, the average is here, but the deviation of the data from the average varies, right? So here, let us say this is 80, let us say this is 10, 15, let us say this is 90, and some other values are also there. From 80 to 10, the deviation is how much? 70. From 80 to 15, 65 is the deviation. From 80 to 90, 10 is the deviation. These deviation, average of these deviations, they are asking. If the average of these deviations is huge, okay, average of these deviations is huge means this is not a consistent data. Okay, if the average of the deviations is very less, if the average of the deviations is very less, then we can say it is a consistent data. See, let us say these are the matches. It goes on like this, okay, and the runs scored by the batsman. So average will be here. Somewhere average is here. If you see, the highest point is here, the least point is here. The deviation is more, but for another batsman, let us say there is another batsman whose scores are like this. If you see, the highest value is here, lowest point is here. The deviation from the average, let us say both of them have same average. Both of them have same average, but the second batsman's deviation from the average is very less. That means the second batsman is a better choice than the first batsman. Are you getting it? So if you can find out mean deviation about mean, from the mean, how much is the data deviating? What is the average deviation from the actual mean? If it is less, that means the data is almost consistent. What is ideal state? If the batsman scores exactly the same amount of runs every time, that means deviation is zero. Right? That means deviation is zero. That means he is the most consistent player. Okay. The green color player, he is not very consistent. But the blue color player, he is almost consistent. So better option will be to select the blue color player. Right? So that is called as mean deviation about mean. Based on mean, you are calculating mean deviation. Okay. Based on the mean, you are calculating from the mean how much it is deviating. Average deviation from the mean. That is the meaning of this. Okay. How do we calculate mean deviation about mean? It's very simple, guys. First, arrange in ascending order. First, find out mean. X bar is equal to what? Sum of these numbers, 24 plus 32 plus 40 plus 44 plus 50 plus 80 divided by 6 terms are there, right? 24 and 32 is 56, 96, 140, 140 and 50 is 190 or 270. 270 by 6 is 45. Now, mean deviation about mean. Mean deviation about mean is modulus of 24 minus 45 plus modulus of, let me write it here, mean deviation about mean is modulus of 24 minus 45 plus modulus of 32 minus 45 plus modulus of 40 minus 45 plus modulus of 44 minus 45 plus modulus of 50 minus 45 plus modulus of 80 minus 45 whole divided by 6. Why we are taking modulus? We are finding the deviation. Deviation is nothing but distance from the data and the mean. Deviation from the mean means distance between the data and the mean. Distance is always represented in positive terms, right? It is a vector quantity, right? Vector only can be represented only in positive, right? Okay. So it is always represented in positive terms. So here 21 plus this is 13 plus 5 plus 1 plus 5 plus 35 whole divided by 6. So average deviation from mean is 20. Average distance deviation from the mean is this one is 34, 39, 40, 80, 80 by 6 is 20, sorry, 80 by 6 is 40 by 3, 13.33. So the distance of data, okay, distance of data from, okay, distance of data from the mean, average distance of data from the mean is 13.33. Like that you can say. Okay. This is how we find out mean deviation about mean. So here, if you have ungrouped frequency distribution table, here first you have to find out the mean, right? First you have to find out the mean. How do you find out the mean? 20 into 2, 40, 20 into 2 plus 30 into 4 plus 50 into 6 plus 60 into 8 plus 80 into 10 whole divided by n is equal to this one is 12, 20, 30. How much is this? 40, 160, 460, 460 plus 480 is 940, 940 plus 800 is 1740. 1740 divided by 30, or it is 58. 58 is the mean, right? X bar is equal to 58. Now, xi minus x bar modulus. So that means we have to take only the positive value. 20 minus 58 is, like 20 difference 58 is 38. 30 difference 58 is 28. 50 difference 28 is, sorry, 50 difference 58 is 8. 2. This is 22. Now, 2 into 38 is 76. 4 into 28 is 4 into 28 is 112. 6 into 8 is 48. 8 into 2 is 16. 10 into 22 is 220. Now, add all these values and then divide it by summation of fi into modulus xi minus x bar whole divided by n will give the mean deviation about mean for this particular data. So this will be 76 plus 112, 188, 128, 2, 188, 228, 236, 242, 252, 252, 452, 472. 472 divided by number of terms is 30. So approximately 472 by 30. I'm just going to use the calculator here. 472 divided by 30, get 15.73. 15.73. So mean deviation about mean in this for this particular data is approximately 15.73. Now, you can even go with assumed mean also here. Okay, you can even go with assumed mean also. The thing is, you have to find mean deviation. After that, you have to find out a plus mean deviation to get x bar. Then you have to do this. So I would prefer going like this only, so that it would be avoiding few steps. Okay. Any doubts so far, anyone? So when you have, so from this point onwards, I will just tell you what to do. Calculation, you please do it on your own, or just take a screenshot and try to do the calculation on your own. So when you have a continuous class like this, take the class mark. Okay, here it is 10, here it is 30, here it is 50, here it is 70, here it is 90. Use the class mark, then same as after this, same as previous method, right? After this point, it is same as previous method. Okay, so if you have continuous class, you just have to take class mark and then do the rest of the process. All right. If you have a discrete class, convert it to continuous class and then take class mark and then go with this. All right. Mean deviation about median. Okay, mean deviation about median. How do you find out mean deviation about median? First, you find out the median. Okay, find the median. Step 1. Find median. How do you do this? First, arrange in ascending order. 20 is the smallest number, then 24, then 32, then 40, then 44, then 50, then 80. How many terms are there? 7 terms are there. So this is your median. Right? So here, the answer is mean deviation about median. The answer is sigma, that is summation of xi minus m divided by number of terms. Xi minus m divided by number of terms, where m represents median. Okay, m represents median. So 20 minus 40. See, basically, average distance away from the median. Mean deviation about median means average distance from the median. Mean deviation about mean means average distance from the mean. Mean deviation about median means average distance from the median. Relate it like that. Okay. And also, this is also modulus. Modulus. Okay. 20 minus 40 plus 24 minus 40 plus 32 minus 40 plus 40 minus 40 plus 50 minus 40 plus 80 minus 40 whole divided by how many number of terms are there? 7. So what do you get here? 20 plus 16 plus 8 plus 0 plus 10 plus 40 whole divided by 7. What is that? 36, 44, 54, 94. 94 divided by 7. So 94 divided by 7 is 13.4. Approximately 13.4 is the mean deviation. Mean deviation about mean. All right. Are you guys getting this? Yeah. Okay. Super. So mean deviation about mean for ungrouped data like this. Ungrouped frequency distribution table. So first, for this you have to find out the median. How do you find out the median? First find out the sum. Number of terms. First find out number of terms. 2 plus 4 plus 6 is 12. This is 30. Right? 30 divided by 2 is 15. 15 occurs cumulative frequency. Cumulative frequency. 2, 6, 12, 20, 30. 15 occurs here. So median is 60. right? First, you have to find out the median here. And the method that we use for this one is, cumulative frequency divided by 2, whichever that now range within which this occurs, that will be the median of this particular data. 60 is the median here. After this, 60 minus 20, modulus of 60 minus 20 is 40, 60 minus 30 is 30, 60 minus 50 is 10, 60 and this is 0, this is 20, right? So Fi is 2, 2 into 40, 80, 4 into 30, 120, 6 into 10, 60. This is 0, 10 into 20, 200. Now, your answer is sum of Fi into modulus of Xi minus M whole divided by total number of terms. See, 200, 260, 460. 460 divided by 30. 46 by 3. That is 15.33. That is the mean deviation, average deviation from the median. Mean deviation about median. Okay. All right. So the next thing is, again, you have a continuous class. You have to find out the median using this formula. First, cumulative frequency and Xi class mark. Find the class mark first. 10, 30, 50, 70, 90. These are the class mark. Cumulative frequency 4, 10, 12, 18, 28. Okay. So n is equal to 28. N by 2 is 14. 14 comes in this range. This is your median class. Right? So what is the median now? L is 60. Lower limit of the median class, 60 plus. N is number of terms, 28 by 2 minus cumulative frequency of the preceding class, 50. Sorry, 12 is the cumulative frequency of the previous one. 12 divided by frequency of the median class, 18. 18, no, 6 is the frequency of the median class. Are we supposed to take frequency or cumulative frequency? Frequency only we have to take. Did we take frequency here or? Okay. Here we should have taken the frequency of the median class. 19 by 38 into 10. So 30 plus 5, 35 will be the answer. Not cumulative frequency, we have to take the frequency of the median class. All right. So frequency of the median class is 6 into class width is 20 here, right? H is class width, which is 20. So 28 by 2 is 14. 14 minus 12 is 14 minus 12 is 2. 2 by 6 into 20. 40 by 6. 60 plus 6.66. 66.66. That is the median, right? After this, 66.66. No. So this is 56.66. Then this will be 36.66. 16.66, 0.33, sorry, 3.33, then 23.33. So after this, the formula like mean deviation about median. Mean deviation about median, sigma fi into modulus of xi minus m, which is this one, right? Whole divided by total number of terms, 28. So calculations will be a little tricky. Without calculator, it will be very hard to solve these questions. Use the calculator during exam. Okay, fine. So mean deviation about mean, mean deviation about median, we have found out. We have seen how to do. The next thing is variance and standard deviation. Yeah, another 10 minutes maximum, we will finish it off. So for raw data, how do you find out variance? Variance is represented using sigma square, and it's very simple, guys. You find out the mean xi minus x bar whole square whole divided by n. That's all. See, for example, for this, what will you do? 10, 15, 25, 40, 60. First, find out x bar. What is x bar? 10 plus 15 plus 25 plus 40 plus 60 whole divided by 5. 50, 150 by 5, 30. 30 is the mean, right? Now, variance, okay, variance is nothing but ten minus 30 square plus 15 minus 30 square plus 25 minus 30 square plus 40 minus 30 square plus 60 minus 30 square whole divided by total number of terms, 5. This will give us 20 square is 400. 400 plus 225 is 625. 625 plus 25 is 650. 650 plus 100 is 750. 750 plus 900. 750 plus 900 is 1650. 1650 divided by 5. This will be 330. So this is the standard variance. Okay, variance. If you want standard deviation, as you can see here, it is just square root of variance. So standard deviation is equal to sigma equal to square root of 330. Okay, whatever is the square root of 330, that will be the answer. Approximately, what we can say, it is between 324 is 18 square is 324, right? And 19 square is 361. So it is between 18 and 19. So we can say 18.2 something. Approximately 18.2 is the standard deviation and variance is 330. Okay. So this formula, remember guys, you have to take the square. That's all. Difference square. Mean and data difference square. Then divided by number of terms, that will give you variance. Square root of variance is standard deviation. Now, how do you find out for ungrouped data, frequency distribution table? So here, first find out the mean. How do you find out the mean? X bar is equal to 20 into 2, 40. This is 120, 40 plus 120, 160, 460, 460 and 480 is 940, 940 and 800 is 1740. 1740 divided by total number of terms is 30. So the average is 174 by 30 is 58, right? So here, after this, what you will do? 20 minus 58 is 38. 38 square is 38 square. Here it is 28 square, 18 square, sorry, 8 square, 2 square, 22 square. Add all these, like 2 into 38 square, 4 into 28 square, 6 into 8 square, 8 into 2 square, then 10 into 22 square. Add all these values. Total number of terms. This will give you the variance, sigma square. Square root of this will give you standard deviation, right? It's all about calculation. Okay, you can do the calculation. This is the process. Once you know the process, you can do the calculation and get the answer. And remember, guys, for this and all, you definitely need calculator. Okay, so this is how you find out standard deviation for a ungrouped frequency distribution table. Now, standard deviation and variance for grouped data. For grouped data, continuous class. If it is non-continuous class, convert into continuous class. If it is cumulative frequency class, convert it into continuous class and then do it. Simple. So take the class mark, same as whatever we are doing here. Take the class mark 10, 30, 50. Class mark is nothing but midpoint, right? 70, 90. After this, same as so n is equal to 12, 18, 28. Okay. And this is variance. Standard deviation is equal to square root of sigma square. Okay. That's all, guys. This is how you find out standard deviation, variance, mean deviation about mean, mean deviation about mode. What and all we have seen so far. Let us just do a recap. So in this elementary statistics, we have seen types of data, range, mean, median, mode, mean deviation about mean, mean deviation about median, variance, standard deviation, and these things we have done it for 3 types of data. What is that? What are the 3 types of data? Raw data, ungrouped frequency distribution, grouped continuous class. Right? So for all these 3 types of data, we have seen range, mean, median, mode, mean deviation about mean, mean deviation about median, variance, standard deviation, and also assumed mean concept also we have seen. right? Okay, fine guys. Go through it once. Very important topic. 4 questions you can expect in TCS and Ninja. Definitely don't miss this topic. Okay. Go through it at least 1 or 2 times. Practice many questions. Okay. See you guys. See you. After TCS exam gets over, we'll do the interview part, resume preparation, and all those things. Yeah. Fine, guys. See you.